Hello and welcome to this week's episode of CAE Quick Tips. In last week's video, I showed you how we can use a Product Template Studio template to help streamline simulation workflows. Today I'd like to show you how we can create a PTS template. PTS templates enable you to perform template-based analysis and rapidly create and reuse CAE workflows without the need to code. They do this by packaging existing design and analysis assets for reuse and by enabling you to quickly and easily create custom interfaces with simple drag-and-drop tools. Last week we looked at a wing flap assembly with an actuator subassembly that drove the up-down motion of the ailerons on the wing. Within the subassembly was this actuator arm that was defined as a reusable component, and now I'll show you how we define it as such. Here we have the basic actuator arm that we'll create a template from. It already has an associated FEM with a mesh and an element size of 0.18 millimeters. In addition, there's also a sim file with a bearing load in one hole and a fixed constraint in the other. Now that you've seen how the base parts are defined, let's jump into the Pds Authoring Tool. Just a note that this application comes bundled with your NX install, although you need a separate license to run it. We opened the same .prt arm_000, and in this application you see information related to the template part. As we saw last week, this part has 3 templates associated to it, 1 CAD and 2 CAE. We open with the CAD template, and what we see on the right is a preview of the dialog box, and on the left how you can control it. Let's look at how the weight feedback is created. As shown previously, when we change the arm length, the part changes and so does its corresponding weight, and there are requirements to keep the weight within a certain range. The value of the weight field is controlled by the number expression P226. When you click on the I tab on the right, you see the part history, as you would in the part navigator, and you see the corresponding value. Now let's shift to the CAE bending load template and create it. First we select UI blocks or groups. Then we select information from the sim and FEM to populate it with. In this case the mesh, and we select which parameters we wish to make available to the user. Note, these are identical to those on the 2D mesh feature. We rename the defaults. And then we can check visually how the dialog is actually looking, and we continue with the other portions similarly. Thus you can see how easy it is to create these templates. We are literally exposing and choosing the pieces we wish to use from the template parts. The key thing to remember is a PTS template is only as robust as the template part it is created from, so a lot of thought must be put into choosing the limits. As always, if you like this video or have any feedback, please let me know below. Thank you and see you next time.